That's it for that. You say something now.
There's not much I can say. I think you're doing all right.
All right. I've got some more.
Go ahead.
Do I
You're
have
on a
some
roll.
more?
Oh,
We'll talk about deadlines.
we have a phone call to make.
Do we have a phone call to make?
Yes.
Is it all made?
No, it's not.
You have to make it.
I'll have to make it. You talk about who the phone call is.
Okay, I will. Don't be gone too long. Mike is even now leaving the studio, and he is calling a gentleman who I believe is in Seattle. Is that true, Bert? Do you know? His name is A.K. Dewdney, Dewdney, and he has written a book called The Planiverse, Computer Contact with a Two-Dimensional World. This is a new book from Poseidon Press, which is distributed by Simon & Schuster. And what it is a pretty detailed working out of a society in two dimensions. It's very much, it has its roots. There are at least two books that antecede this. One of them is called Flatland and was written, I believe, in 1884 by a Dutchman. And then there was another book that followed it in, I think, the 1920s or 30s, written by a mathematician. What was his name? I don't remember. I don't remember any of these guys' names. I wish I did. I should have brought this stuff with me. Anyway, one was called Flatland, and the second one was called Sphereland. Sphereland was an advancement on the idea. Flatland was about a two-dimensional world. Sphereland was about a three-dimensional creature visiting a two-dimensional world. I remember there was a part of it where they were visited by a sphere, and of course, as he fell through the two-dimensional world, he started out as a dot, and the circumference got larger and larger to a maximum, which was, of course, the circumference of the sphere, and then as he continued on through, there was just a dot left, and then he disappeared, and of course, this was entirely amazing to the people who lived in the two-dimensional flatland. Anyway, we're going to be talking to Mr. Dewdney, who has written a book called The Planiverse. His idea was that he contacted the two-dimensional world through a computer. As a matter of fact, through a computer program, which is an interesting idea and certainly very popular lately. Did you find him? Is he there? Well, then let's talk to him.
Mr. Dewdney, are you there?
Sure am.
Well, welcome to Hour 25.
Thank you very much.
Okay, and you're on with myself and with my co-host, Mel Gilden, and Mel is a fan of two-dimensional and of multi-dimensional universes and books thereof, so he's going to ask most of the questions. Go ahead, Mel.
Oh, well, thank you very much. I read the introduction to the book, where you talk about you and your students and going through the 2D World program, and I got the impression that a lot of this introduction was true. Did you ever actually do a project like this?
Well, to be perfectly honest with you, the closest we've ever come to a project like that was when I had the students write a simulation program to simulate predator-prey relationships. We had little two-dimensional sharks swimming around in a two-dimensional ocean, chasing little two-dimensional fish, and we were. It had a kind of scientific aim, and that was to see to what extent we could sort of confirm the results of a set of equations called the Lotka-Volterra equations.
What does that mean?
I think this gave me the idea, partly anyway.
What are those equations? What do they describe?
Well, they're differential equations that describe the ratio of predators to the ratio of prey in a very simple predator-prey ecosystem.
Now, you mentioned that also in the introduction, just sort of in passing. I haven't read the whole book. I've read the introduction. I've read the acknowledgments. It seems as if a lot of people had a lot of input on this book. Some of the things are very detailed. You've worked out two-dimensional clocks, two-dimensional hinges. The only thing you couldn't figure out as of the printing of the book was how to do wheels and axles.
That's right, and I've since come to the conclusion that a two-dimensional wheel, at least of the kind that appear in our own cars, is impossible in a two-dimensional world. We had a contest last summer in Canada with several hundred entries. This was all triggered by a radio show called Quirks and Quarks. And these several hundred entries, none of them, and some of them were by engineers and other professionals, but none of them succeeded in coming even close to a workable two-dimensional wheel. You know, I'm thinking lately that this is a great advantage because if the Ardians, these are the people who inhabit the planet described in the book, ever did succeed in inventing a workable car, they would squash all life forms flat, since there is only that one-dimensional surface on the circular planet of art, and there's no way to go around anything. So
Well,
it would be a tremendous ecological hazard.
Is, okay, I'm thinking now, having seen the example that you used, the very first example in the book, where you have two, how can I say this, two circles of two-dimensional matter. And you say, ultimately within this imaginary plane, it will move far from the Earth itself, unless, of course, it encounters a similar object. Doing so, the objects meet and suffer what physicists call an elastic collision. Anyway, there is no room in two dimensions for them to move sideways around each other.
Yes.
Okay. Now, I'm looking at this thing, and I'm looking down at it from a third dimension,
Yes.
and it seems to me, just looking at this picture, that one of them can move to the left or to the right and go around him that way.
Absolutely, but I guess one of the things I should have stated there but didn't was that one assumes that these two objects are on a collision course. It's just a kind of a lighthearted thought experiment to help readers grasp what it means to be two-dimensional and how you can still have interactions between matter in two dimensions. And if there's ever any difficulty, you can give everything just a little thickness and imagine two coins sliding across a tabletop, if you want. Like, if they're on a collision course, they rebound and they strike each other and rebound. The point is that there's no room for them to go above or below each other.
That's true. Yeah, I understand that. Had you, how did you become interested in a two-dimensional world? I mean, what got you started on writing this book? You're not a fiction writer normally. You're a teacher. Is that true?
That's right.
Yeah. What got you started then?
And a researcher, I might add. These are my two main loves in life. But I guess there are a variety of sources that kind of triggered me into this. One was certainly reading Abbott's classic work, Flatland, which I must say, quite by coincidence, turns out to have been published exactly 100 years ago.
Really?
This book was actually going to come out in 1983, and it was delayed somehow by for some inexplicable reason. It was delayed until 84, and we all suddenly realized, more or less at the last minute, that it was exactly 100 years since the appearance of Abbott's book. Well, that was a nice coincidence. But it was not only Abbott's book which sort of influenced me here. I think it was also one summer in 1978, I was reading one of those popular cosmology books that describe how our own universe in terms of a two-dimensional analogy. You know, the question of whether our own universe is a flat shape, like a flat sheet, or is it like a sphere, or is it like a saddle shape? But that's only an analogy, you see, a kind of metaphor. But I sort of took those models of possible universes literally and began to ask myself, well, could you actually have two-dimensional matter, two-dimensional physics, two-dimensional chemistry and biology even? And within the space of a few months, I had worked out a set of notes and playing with this in my spare time. Ultimately, I sent this to Martin Gardner just for fun, and he published it in his then well-known column, Mathematical Games. That in turn created a whole bunch of publicity, over 2,000 letters, as a matter of fact, all of which I had to answer, but many of which were from scientists, and I ended up with something like 25 or 30 usable theories or speculations, which I went ahead and incorporated into this book. So it's hardly my own creation.
Well, you put it all together.
Sure.
Do you see yourself going any further with this, perhaps taking all the ideas in the book and having a second volume in which you will perhaps write an adventure story of some kind, some dramatic piece of work using all these ideas?
Well, since you didn't read the book, you might not realize that that's already been done.
Oh, is this an adventure story then?
It is already, yeah. It opens rather like as if it's going to be a kind of natural history of 2D.
Yes, that's as far as I got.
Well, we quickly encounter a little character called Yendred, a two-dimensional being who is in search of the beyond, the mysterious realm of the third dimension.
Oh.
As he walks over the surface of his planet, which is, after all, only a line, he encounters everything in his native land of Panisla and climbs the heights of Dalradam, which is a central plateau that divides the land of Panisla from the land of Vanisla. And on the heights of Dalradam, he meets the wizard Drabik. And it's Drabik who, by his mystical powers, introduces our hero Yendred to the third dimension.
Well, now, if he's walking around this planet and it's pretty much just a line, isn't he then just really working in one dimension?
Well, I know it sounds like that, but let me hasten to add that the surface of our own planet is essentially two-dimensional in exactly that sense.
Oh, yeah, I guess that's so, isn't it?
The way to picture Yendrid's home planet of Ard is to imagine a phonograph record, and all the inhabitants live on the rim of that record. They perch on it, as it were, held there by two dimensions, and the gravity of this planet acts toward the center, where the hole in the record is. Of course, that's all underground as far as the creatures on the rim are concerned.
Now, my first thought is, and this is because it's difficult to think two-dimensionally, it seems to me that if you have a vanishingly thin person standing on the rim of a vanishingly thin planet, he's going to have to be a terrific balancer.
No, you see, as I say, there's no sideways for him. He can't slip off.
He can't slip off because there is no sideways. He's living in a universe that has no third dimension.
Right. I did get one nasty letter from all those 2,000 letters that came about as a result of the Scientific American article. And this one person wrote me from Alabama, and he said, "Why do you waste the taxpayers' money on something that doesn't exist?"
Well, you weren't wasting were you? I mean, taxpayers' money? Huh?
I thought even from the United States, but never mind that. He went on to say that since anything which didn't have any thickness didn't even exist, the universe has a 3+1 universe, 3 physical dimensions and 1 of time, and the 4 are together tied in very tightly by Einsteinian relativity. But I think it's fun to take the mathematical idea of dimension and to extend it, if you like, metaphorically, and imagine that this universe, this planiverse, exists embedded inside a third-dimensional space, which may not be time.
So space itself, three-dimensionality is not, it's a characteristic of the space itself, and there could be space that has a two-dimensional characteristic or even a one-dimensional characteristic.
Oh, yes. I mean, I don't know whether these things actually exist, but my main interest, early on anyway, was in seeing whether, when I sort of applied all the two-dimensional physics and chemistry which we had developed together, whether any contradictions would result. And funny thing was that none ever did result. We seem to have designed, if not created, a consistent two-dimensional world, a world, moreover, in which things had to have a certain form, even right down to the biology of the creatures involved. Kind of makes you think, well, if such a place did exist, it would pretty well have to look like this.
And I guess it does.
And this kind of gives my writing a certain conviction, which I think impresses the reader to the point where the reader thinks, hey, this really does exist.
Well, it convinced me enough that I thought at least the beginning of your introduction was true. You know, that you had really made a model called 2D.
Sure.
Yeah, I thought that was true.
I tried to make it believable, of course, because I came finally to realize that I am, in fact, writing a novel. And
were all those students invented, or were those real names, or were those real students?
So they're taken. They're sort of bits and pieces of various students I've known along the way, and I think that's what helps to make them believable as characters.
I must say, the two-dimensionality aspect of the book leads me to wonder if you've gotten any reviews which start off by talking about the lack of depth in the book. I see in the about the author, pardon me, it says, pardon me, your major interests for the last 20 years have been discrete mathematics and theoretical computer science. Right. What is or are discrete mathematics?
Well, discrete mathematics is really a collection of various kinds of mathematics, all of which have the property of discreteness. And they are opposed, or you can think of them as sort of contrasted with continuous mathematics, which is the more classical kind. And let's just give you a quick analogy here. You could say that continuous mathematics might well deal with a piece of string, whereas discrete mathematics would deal with a handful of marbles.
Oh, that's very interesting.
See what I mean? It's like you're dealing with discrete collections of objects and their properties.
Huh.
Sets and subsets and so forth. This kind of mathematics, by the way, it lies very much at the foundations of theoretical computer science, and the kind of thinking you do in discrete mathematics is very much the kind of thinking you do as in most branches of theoretical computer science.
Huh. It's been said by some very smart people that on a list of impossible things, one of the most impossible is time travel. Now, if time is, as H.G. Wells said, another kind of space, and has been said since, it's another kind of dimension. Do you believe that time travel is possible through a machine, say?
Well, certainly there's at least from a theoretical point of view, and I'm not a physicist, let me disqualify myself immediately, but my physicist friends tell me that there's really no problem with, if you could construct a spaceship that could travel at close to the speed of light, at leaving the Earth and going on a voyage which to you might last only a few days, and come back to the planet Earth, again with your own clock showing only a few days having elapsed, and find that you arrive on Earth 1,000 years later.
But is there any way to go back in time?
Not that we know of. I did talk to one theoretical physicist in Oxford who told me that there was a recently developed theory involving an extremely massive cylindrical object, which if you could get it out in space and spinning fast enough, excuse me, then close to the surface of that rapidly spinning object, there might be a kind of time dilation in which you might succeed in getting back to earlier times. That's very vague, and to me it's nothing more than a kind of suggestive little story. I don't really know what kind of theoretical work lies behind it.
I've been thinking about this for a long time. I mean, like years. When I saw The Time Machine when I was 11 or 12 or whatever it was, it changed my life.
Oh, yes.
In a very literal way. I mean, I ran out and read the book, and all my school notes have pictures of time machines on it, and even in my own elementary way, I came up with an algebraic equation for time travel. It's very wrong, but I thought it was pretty clever for a kid in junior high school.
Absolutely.
So the question that I have is, now the people in the two-dimensional world obviously exist in time. They have one thing happens after another,
yes,
and their time sense is very much like ours, even though they live in a two-dimensional world.
Right.
Okay. Now, given that, and given that fact,
yes,
would it not then seem that time is not the fourth dimension, but some sort of meta-dimension that would oversee all the other dimensions that may be?
Well, metaphysically,
sort of an
I
n
mean,
plus one dimension.
I say mathematically, rather, time is a fourth dimension. I mean, it is a coordinate, if you like, the coordinate t, and what you're asking really is perhaps best answered by saying that in the sequel, which my editors have already been urging me to write, I intend to have the wizard Drabik follow what are called world lines. Now, everybody in the planiverse, you can think of the planiverse as moving, and as it moves through the time dimension, so to speak, this two-dimensional surface, everybody and everything in the planiverse leaves behind it a kind of tracery. You see, as, for example, if a disk were rolling across the surface of Ard and it hit another disk and rebounded, then the tracery left by those two disks would resemble two rods that come together, join, and then go apart again. It's a little hard to visualize, but the point is that everything leaves a kind of trail through time and forms a kind of solid or three-dimensional object, which is a picture of that object in eternity, if you like. Now, the wizard Drabik will be following world lines and taking Dendred into the future, where he sees his own death, and into the past, where he witnesses his own birth. And in so doing, they create a number of very strange anomalies. For example, they leave new world lines, which traverses the time dimension and creates a new time dimension. It all gets terribly confusing, but that's part of my purpose, is to have a little bit of fun with this.
Wow, that sounds terrific. I hope you'll send us a copy of that, because it's real interesting. And if you're ever in Los Angeles,
He was. It was not. It's why. I
Oh, we
saw
missed it.
now. Yeah.
Oh, I'm sorry.
Are you going to write the sequel?
Pardon me?
Are you going to write the sequel?
It's hard to say yet. I guess, for example, if the Planiverse book just doesn't go anywhere, then even if I did write a sequel, I guess I would find it hard to get published. But the early indications are that it is going to go somewhere, although who knows where. And so I think, yes, I'll probably talk into writing a sequel, and I might start it this summer.
Well, good luck, and we will be looking forward to it. And if that comes to fruition, you will definitely have to be on the show next year in Los Angeles.
I'd love to.
Thank you very much for being with us, Professor.
Thank you.
Good morning.
How about
That
good night?
was that too.
Yeah.
That is Professor A.K. Dewdney, who is author of The Planiverse, Computer Contact with a Two-Dimensional World. It's published by Poseidon Press, and
if you're into this sort of thing, it's really very interesting.
along with Flatland by Edwin Abbott, and what's the other one?
And, well, it's all right here in the front. And then there's another one called Sphereland, which was written somewhat later. Let's see, Abbott's and Hinton's and episode, well, let's see, Berger's Sphereland, and that was, like, I think, written in the 60s sometime. Somewhat
Okay.
later. Anyway, all three, they're sort of all companion volumes.
And probably ought to own them.